Before I go into the translation code and add convert to string instead of using print int, I kind of want to go over what the code does because I've edited it a little bit. So we'll just go line by line. Value is placed into EAX. It's moved into there, into that register. And because it's in brackets, it's the direct value stored there, not the location. We call prep convert, which is something I've added because you may need to convert multiple times. And so the index needs to be reset. This moves 0 into CL, and then it moves the 0 that's in CL into the string index so that that value gets set to 0. So essentially sets the index to 0. Convert into string checks whether or not the value is greater than 10. If so, it divides it because it knows that there's more than one value which it needs to act on. Otherwise, it skips directly to the end because there's only one value that it needs to work on. And so all it has to do is add 0, which 0 is 48 binary, that value. So it'll move it from binary 0 to the character 0, the string character 0, which is something I didn't really mention in when I was doing the first video. Okay, push EBX kind of moves EBX out of the way. It stores it into the stack, and then you can use EBX here to get the array position. So here's the array position, and then here's the index in the array. And then it adds the index so that you can move 1 byte into that location. So when we have the brackets here again, on EBX, we are referencing the direct memory location, not the register itself. Okay. And then we increment CL, and then we move it into the index in order to increment the index. Div just divides the thing by 10, pretty straightforward. And then we call convert to string again, where it checks if there's more. If there is more, it divides it again, etc. Okay. So now that we've gone over this code, which is just the raw assembly, how are we going to add that into this code so that it can be translated? Now, you have to find a way when writing code and doing a translation to have sort of a dictionary or a definition of what something is, so that if it has to be changed later, you don't have to go through and change every single reference. So I use two main files for that, defs, which is just language-specific definitions, not assembly. And then I use ASM 16-bit, which it should be renamed to just ASM 86 instead of 16-bit. Because it's not specifically 16-bit. I thought I was going to do specifically 16-bit, but I didn't end up doing that. And you can see that there's different registers, different event names, timer event, replace values to know when to replace with something and when not to, a bunch of jump conditions. Anyways, you get the point. So what I need to do is I need to go to where we are currently doing the logging, which should be in, instead of boot sectors, not timers, not graphics, it's in logs. So these are the calling of these sort of logs. And when we log an int, okay, we were moving a value into the AX register and then doing all that math on it. But we're not going to do that anymore. So, and we're not going to be doing logging byte either. So all of this, for now, will be commented out. So we're just going to go ahead and do a multi-line comment so that we can collapse it, because this is something that's essentially going to leave the code and not be used anymore. Now that's going to generate errors elsewhere, but that's okay. Now, these log calls are calling a built-in thing. So we need to find where that is stored. It's not an ask. It should be in, not bootloader, not sectors. It should be in text, I believe. So let's go until we find text. This is stack math arrays, keyboard. Aha. Oh, I didn't put a text. Well, it doesn't really matter. Here it is. So here's the print log. From now on, we'll just be using this one. This one, the print int, will also get commented out. So what we're going to do is just do a multi-line comment there as well. We want to preserve the code just in case we have to reference it later. So multi-line comment, since it's collapsible, is the best option in my opinion. But now we will need a text region. Now you might be wondering why I'm using C#. Basically, you need a language to do the translation in. And I'm skilled with C#, so I decided that would probably be the best thing for me to use. And eventually the language will be rewritten, the translator will be rewritten in its own language, so in PHI, and it will be something called a self-supported language, meaning I will not have any C# dependencies used in it. Now, C# is multi-platform now. .NET 8 can run on any machine, so it wouldn't be that big of a deal. But if you're going to be building operating systems, you don't want to be dependent on a different operating system and a different language to build it. So it'll be self-supported in the sense that you will write the language in PHI to expand the language, and that's an ideal scenario. So I'll talk more on that later, but not in this video. So what we need in text is we need a public static, so it's accessible, list, and then not, instead of it's suggesting ask input, we don't want ask input here. We actually want it to say convert to string. And I think we're going to say convert int to string because float will take a different process. So we'll just do convert int to string. Okay, and then we do equals new list. All right. Okay, so now we need to move in the code. So to do that, I like to do a little trick where you figure out how many lines it takes. And you just sort of like do this, you know, in a bunch of these lines so that we can do a multi-line paste from the selection. And I believe it should work going from Visual Studio Code to Visual Studio. So if it doesn't, there's another way we can do it. We can just copy it into a text file and do it from there. But this saves you a lot of time. So yeah, there we go. So they don't intend you to use alt again, I guess. So it was one of those things. Anyways, so it puts it in directly like this, which makes it really easy. So we need to, instead of, and if we run this, we're going to run into an error. And that's perfectly fine because I actually want to run into the error so that I can start removing these. Okay, so log byte is no longer going to be used in the logging code. Log int won't be used. What I really want though is the includes. So I have an auto include function here. And what we need to do is Control D. We need to comment out one of these. And then we need to replace dot and then what did I call it? Convert string to int. So that it's accessible inside of the includes. And then these other ones I'm going to leave because we're going to go in and alter them. So specifically we'll do int and then, yeah, okay. And we don't need this anymore. Okay, so when we try and log an integer, what needs to happen is we need to do a log string instead. However, we need to move into the SI, the correct value, and that's going to be called value string buffer. I think I may rename it, and value string buffer is just this. So we're going to call this value int to string buffer, and this will be int to. That way we're very explicit about it. That way I don't overwrite it later. We're going to go ahead and copy that. And this is a variable include. So we need to go to and see if there's a variable include that already exists that should be used for this. I don't think there is. It would be in logs if it was. We just have this. So what we're going to do is add this to this text region, and we will call it print convert variables. And then we will, let's see, we have two necessary variables. And we'll go ahead and add that to the includes, which is in here. Control Z, control find. No, I don't want line number. Auto includes text. I want to look for something that is specific to variables. It's called var start. All right. So control D, convert variables, and this instead of the includes becomes the var start. That's where it needs to be inserted. Okay, now we can finally take on these codes. So we're just gonna comment out Boolean and byte values. And just work on int. So we don't need a vname anymore. Vname is used right, okay. So what we need to do instead is this doesn't exist anymore, so we get rid of it. We need to call the convert first, and then we need to call the insert. So the last value we need in here inside the logging code, which is up here, is a public static list string instruct log int, and then bits. It's technically, we're using 32 in this, so we'll just label it as 32. This, I believe, would be ESI if it was 16, but you don't actually need, or 32, but you don't actually need, you just need 16. In fact, you probably don't even need 16 because it's 1 byte at a time. But anyways, so we will need a call print log in here, and we will need an SI move. but we'll also need to call the prep and the convert. So call prep. And I need to look at my code again to see what it was called. Prep convert is what it's called. I could consider renaming that, but for now I think that's fine. And then we need two more things, which is convert, but we also need to move. So, and the prep convert can happen before the moving of the value into the register. So yeah, we'll just grab that and put it here. And then this needs to be a variable. So we'll replace this with, I think it's called replace var name. Okay. So that's done. Need to copy this over. Let's see. I believe we just do, actually, log so subcode equal subcode merge value. Okay, they're replacing the code start with. Okay, I need to peek this definition to see if it's what I think it is. Yes, okay. So I think most of these were one single replace, but I need to make sure that they're both going in. So I think we'll pause, use a breakpoint here. I believe there's already a log int in that code. So we'll just give it the default file and see if it hits. No. So what that means is I need to go to hello.phi. Aha, yeah, that's right, there isn't. And I need to put a log in there for an integer. So we'll just do int test 12 log test. Okay. Okay, here we go, it hit. So now we need to inspect the subcode, make sure it's correct. Call prep convert, good. Move, okay, we need the var name there. Convert int into string, good. Move si value, call print log. Aha. So we only need one print log. And I believe the reason there's two there is because this one probably already has it in there. Yeah, call print log. So that means that this one needs to be removed. Actually, because there could be multiple, it might be better to remove this part and just use that since it's a duplicate. That's probably best. So we'll go ahead and remove that. Now it should be correct. Subcode. Call print log. Good, there's only one. Okay, so this vname, what is it? Test. Okay, you're the thing that needs to be converted. So what we need to do next is insert vname by doing subcode equals asm dot replace value subcode. The name, no, the key is, I believe, asm.var name, replace var name, and the value is vname, and then subcode equals asm x86.replace value subcode, and then the replacement is defs dot place value start, and then the value that's being replaced is actually the defined variable name. So because it's the defined variable name, called value string buffer, I need to specify that it's a string buffer and that it's specific to, so that would go in defs because it's not a assembly specific thing, it is a name. So I believe that's where I should put it. Those are var types, math operations. So we don't have a spot for that, so we'll just put it here. So this is going to be called probably var store int to string equals, and then we need to make sure that it's the same that's in this code. So probably should copy it from there. In fact, I don't think, let me find, it's up here, isn't it? No, it's in text. It's in text. Here we go. And it needs to replace this as well, so that I know that it, because these will throw an error. This is the buffer, so let's make sure everything that needs a buffer is there. I believe that's the only one that needs a buffer. So let's grab this one too and replace, because these will throw errors. Okay. So index versus buffer, other than that, they're the same. So this is into string, and we'll just call it var to string buffer. And then and I'll be adding this to these variables, index. So this would be the index. So now that we have these values defined, we need to replace our code with them so that if they change, we don't have to have problems. So to string buffer plus, and then we just copy this as well. And we remove that and make sure there's a space, and this is called index. Ah, I accidentally hit the wrong button. Okay. So now that that's done, we need to go back to where we were doing the code here and replace that value with defs.var into string buffer, I believe. Move that extra comma, semicolon. Okay, now we can run it and see if it did it correct, if the code output looks right. Okay. Call prep convert. Okay, I just realized an error. This will work, and we can test it real quick by opening up Godot. and running it. There is an error though that I'm seeing. Let's see if I have that code still there. Yeah, I think it was test. Yep, test. Now it may throw an error at first, yeah. There we go. So it works, and I know it works. But can you guess where the error is? And we'll look at the code, make sure, yep, value int string buffer, it all worked. There's no, you don't see any include for, you just have a prep convert to string, and a print log. You don't have a print int, so it's working. But let me show you how to make an error, how to exploit this logic. If we do int value, or large, we'll call it large, and we do 1, 2, 3, 4. Okay, 1,234. And then we go log new line. Then we go log large. You'll see what I'm talking about. So here it's correct. Okay, so this is fine. But now if we reverse, so if we do large here, and then do value here, it'll be obvious. Yup. Yep, can you see what's happening? So 34 is not getting cleared because 21 is only 2 characters. So 34, 1, 2, 3, 4, that 3 and the 4 is never getting overwritten. So that's an error. I may decide to fix that later though, because that involves iterating over the entire index and clearing it out. There's probably a better way to do it, but for now, this is where I'm going to end the video.